our dimensions at all? You agree with me? Whatever that cost is per square inch, that's not going to affect our dimensions. So when we find the derivative, we're finding it with respect to r. Now, what is that derivative? That's going to be the easy piece, isn't it? Finding the derivative of this. There was the property that says that, well, if I had 4x squared, it would be the same as 4 times 2x on the derivative. So it's 4 times the derivative of that. It's that scalar multiplier that we always see cropping up with everything. Do we agree on this? Now, if I'm going to minimize this rather, I take the derivative, and now what do? After a while, we just repeat the same steps, don't we? Take the derivative, set it equal to 0. If I set it equal to 0, is the cost per square inch going to change? So it can't be 0. You can't, if that was 0 per square inch, that'd be pretty nice, but it's not. So the only piece that's going to help us is this 4 pi r minus 28.88 divided by r squared. So now it's just a matter of kind of solving for r on this. 4 pi r times r squared equals 28.88. R cubed equals 28.88 divided by 4 pi. So r should be the cube root of that. And I'll just go through this again. I'm assuming that 2 times s is not going to be 0. If it does, then you got kind of a stupid problem here with the cost per square inch being 0. So it has to be this. If that's the case, then I'm going to set these equal to each other and multiply both sides of that equation with r squared. And then divide both sides by 4 pi. So I end up with r cubed is 28.88 divided by 4 pi. Take the cube root of that, and the approximate answer should be something around 1.32 inch. Now you think about a right circular cylinder with an energy drink in it, that's about right. A radius, it means that the entire diameter is a little more than 2.5 inches in diameter. So that's about, if you think about it, that's about right. Okay, now, does that minimize or maximize? This is a possible extrema. Are we in cubic? We're in inches. So the linear measure would be inches. The volume is the cubic inches. So now, does this minimize or maximize it? So now what do we have to do? Take the second derivative, okay. And again, remember, we're not interested in the actual value. We just need to know, is it positive or negative? And I can see right now, this is going to be positive. This is the same thing as 2s times 4 pi, that's a positive quantity, plus 57.76 divided by r cubed, that's a positive. We've already established that 2 times s is positive, so if I put anything in here, it should be a positive value. Okay, so positive value. So is that So C prime of R is positive for all R. Therefore, the cost function is concave up everywhere, right? Okay. And R equals approximately 1.32 inches will minimize cost. Now, what is the height? Because we want to know both dimensions. So now to find the height of that, we're going to have to go back into the volume and come up with what that would equal. Don't you love these problems? I mean, you think about all the work you do and, some of the work you do is just crunch the numbers and you get an answer. You don't know what it means. Now you know what this means. You got a can that's about 2.5, a little more than 2.5 inches in diameter. And if you look at this, it's about 5.28 inches high. Now, I don't know what Red Bull is, but I don't think it has those dimensions. I think this is another drink instead of Red Bull, because I'm sure the diameter of that is not 2.5 inches on that. Okay. These optimization problems, I don't think I gave you 20 of them, did I? Probably less than 10? There's 12 of them? Well, I gave Zach 12. Okay, I give the rest of you 7 of them. So, but whatever you have, you've got to spend some time with them. So now, Laura, you spent some time with them. You're saying you didn't get this answer?
Well, because mine was 4 times. So.